Hi, my name is Imran Chaudhry, and I'm the Chief Architect for Healthcare and Life Sciences at MarkLogic. We will be talking about the Data Hub service and the scale testing that we did for a very large pharmaceutical customer. I'll also be joined by Drew Wonchowski, who will be talking about the tooling that we use to do the scale testing. From an agenda perspective, the first thing we'll do is cover the scale testing environment. Then we'll look at ingestion rates and autoscaling of the ingestion subcluster. Then we'll look at capacity, ingestion, and curation rates together. And then we'll look at the query rates and the autoscaling of the query subcluster. Finally, at the end of the results section, Drew will go over the tools that we used to perform the scale testing. So let's dive into the scale testing results. First, the obligatory disclaimer. We used a very specific data format, the SAP format for sales lines and sales headers. And we did a very specific set of curation and a very specific set of queries. So your mileage may vary depending on your use cases and what you're trying to do. So from a customer perspective, the customer wanted to bring in change data captured data via NiFi or Kafka and move that into MarkLogic's staging database as is, which is a normal way of thinking about data in the Data Hub, and then do one-to-one configuration-driven mappings and custom business mappings to create harmonized curated data, and then they wanted to do consumption of that data. So what we did is we created a Java data generator using the data movement SDK that simulated sending data in via Kafka or NiFi into the Data Hub service. We did the curation and mapping using the standard Data Hub service steps, and then we ran queries using the same Java program to get the data out of the Data Hub service via the REST APIs. When you spin up a Data Hub service, you don't just get one cluster. You get actually 4 subclusters. You get a data subcluster and then 3 evaluation node subclusters. One subcluster is used for ingestion or ingestion and curation. A second subcluster is used for real-time queries via REST, Node, and Java. And then a third subcluster is used for long-running analytic queries for Tableau, Power BI, machine learning, or AI, or any of those sorts of use cases. So for the testing, what we did is we ran a very heavy load against the curation and ingestion clusters and measured peak performance rates after the cluster had scaled out to its maximum capacity. That, of course, put a heavy load on the data nodes. And then once the data was loaded, we also ran heavy query loads against that heavily loaded data and were able to exercise the operational clusters. That's what we did the testing on, and those are the results we're going to go look at. Since our customer was also interested in Kafka, we did some independent Kafka testing and were able to hit 24,000 peak transactions per second with about 40 threads or 40 vCPUs, and that was one very large cluster server, and that was good enough for our customers' requirements. For the ingestion testing, what we did is we generated synthetic SAP sales order lines and headers. We had between 1 and 10 lines per header for an average ratio of 5.1 lines per sales order. The average size of the sales order record and the sales order line records was about 3.5 KB. And then we measured the peak burst ingestion rates as documents per second. Because we were using the REST API, we wanted to be efficient about it. We sent in micro batches of 100 documents at a time. And here are the results. So MCU is the MarkLogic consumption units, and we tested against 64, 128, and 256. You can see that this is a factor of 2 scaling. We also did a factor of 2 scaling on the y-axis where the rates are measured. So the rates that we got were for the smallest cluster, we got 3,000. For the mid-sized cluster, we got about 6,000 documents per second. And for the larger cluster that we tested, we got around 12,000 documents per second. And as you can see, this scales very, very linearly. For the largest cluster size of 16K MCUs, we could theoretically hit around 800,000 documents per second. So now let's look at what was happening under the hood with regards to the instances. And here you can see that the starting instance for the ingestion curation cluster was one instance. And you can see we don't have any data coming in and no traffic. And then we finally started hitting the system hard. And that poor single instance basically hit 100% CPU when you combine the user and system CPU rates. After about 5 minutes, the system detected that, oh, we need to get more capacity, and then started spinning up another instance. And so now we're at 2 CPUs, and you can see the CPU usage, two servers, and you can see that the CPU usage is going down. And finally, at the steady state, we moved to 4 instances with about a 50% CPU usage on each instance. So the next thing we did is we tested out capacity, ingestion, and curation combined rates for the different data hub sizes. So what we tried to do is we tried to load up the data hub service to 75% of the capacity from an MCU perspective. Then once we had that 75% loaded capacity, we went ahead and ingested and curated 1 million new records. We found that, again, we were doing it 100 records at a time. We found that for all runs, we were able to get the end-to-end ingestion to curation ready for output content to be less than 200 milliseconds. In fact, the worst run that we saw was about 105 milliseconds. And again, the document capacity here includes both raw and curated data. It's interesting to note that we did not optimize the record capacity. There were multiple things that we could have done that we didn't do, like aggregating raw data into into combined files and only referencing the raw data instead of copying it into the final database. So here are the results. Let's take a look at the yellow bars first, which is the record capacity. So for the smallest system, we put in about 380 million records. Then the next largest, the 128 MCU, we were able to get in about 700 million records. And for the 256 MCU, we were able to get in about 1.5 billion records. And for the 1.5 billion records, this represented about 7 terabytes of data. Then the green bars are the curation rates, and so ingestion and curation combined rates. So we got about 1,000 for the small unit, 1.2K for the mid-sized unit, and 2.2K for the 256 MCU system. And when you project this out to the larger capacities, this would give you an ingestion curation rate of about 100,000 documents per second, with about 90 billion documents in the system for this particular kind of data. So then what we did is we said, okay, now that we have all this data, let's query it. Again, we wanted to do a long-running query, so we queried about 1 million random records. We wanted to do some work, so we took the sales orders, and then we found all of the lines for those sales orders, found all of the dollar amounts for each of the lines, and added that up to get a final total for each of the sales orders. The average latency for all of this work was about 20 milliseconds for all of the runs, including all of the different capacities. And again, the document capacity is both raw and curated data. So the yellow and green lines are from the previous graph. All that we have done now is we have added the query capacity rates, and for the small instance we were at 11,000, for the mid-sized instance we were about 15,000, and for the larger instance we were at 22,000 documents queried per second. And when you scale this out to the 16K cluster, we're looking at 900,000 queries per second, which is a rather large number. So looking at the instances, we started off with one instance in the real-time query operator group. As we expanded, as we hit the system hard, it expanded to 3 instances, and then because this was a larger setup, this is the 256 MCU setup, it expanded to 8 instances, and the CPU capacity went down to about 50% again, based on the endpoint that we're looking at right here. So to summarize, we did a lot of testing. For the Data Hub service, we measured the record capacities and were able to easily get to the billions of records. We measured ingestion rates, and we were able to get to tens of thousands of ingestions per second. We measured curation rates, and were able to get to tens of thousands of curation documents per second. And we measured query rates, where we were able to hit in order of magnitude larger than that as well. And you can see that the performance numbers scaled quite linearly with the MCU size. And what we did in this particular graph is we decided not to do a log scale on the y-axis, so you can see the huge dynamic range that we have for the different MCU sizes for the Data Hub service. I'd like to thank everybody for watching. I'd also like to give you our information. My email and contact information is right here. Feel free to reach out to me if you have questions and are interested in testing out Data Hub service. And Drew's information is right below me here. And the next section of this video will be the tooling that we use, and Drew will be going over that tooling.
Thanks, Imran. Hello everyone, and my name is Drew Winchowski. I am a solutions engineer with MarkLogic, and I'm here today to talk to you about the Data Hub service and scale testing what we did to get to those numbers that Imran previewed for you earlier. We're going to focus on 2 major areas today for this load testing: ingress of data and egress of data. We ran this load test within AWS within a EC2 instance configured with a JVM. This JVM handled both the ingress and egress of data, and we're connecting remotely to a MarkLogic Data Hub service within the same AWS region. Outside of the scope of the MarkLogic SDK, we created a Data Hub data generator. We mock data here for the sales orders and the sales order lines. We templatized this data and randomized the values. This gave a representative set and allowed us to get to the number of records we needed to fill up the queues to produce a real-life scenario. A producer thread was running and filling up a queue. All this was done in memory. However, you can replace this with a live feed of data from any number of sources, say a JDBC connection to an existing RDBMS. You can make remote server calls and pull in data from an HTTP endpoint, or you can connect to queues and pass that data over to the MarkLogic SDKs. The MarkLogic Data Movement SDK is part of the Java client provided to you from MarkLogic. We created a consumer thread in our Java program that read items off of the producer queue. This SDK was used to create a write batcher, and this write batcher can be configured to run in parallel threads. We can also tweak the number of records in a batch, so we minimize the number of network calls, and we can even specify the server transform for some pre-staging of data. The data movement write batcher looks a bit like this. We create, we configure, and we start the batcher. The batcher knows everything that it needs to connect to the MarkLogic Data Hub service. The host, the ports, the users, etc. It also knows the network topology of that Data Hub service and executes the work against those particular hosts that are configured within the Data Hub service. Within the Data Hub service, we target the specific load balancer for the curation workloads. Here, these job threads are loading the data and sending them over to the Data Hub service. This work is then sent over and a response is returned from the Data Hub service. The notifications here that we see on the lower corner here are configured in the batcher. So when the batcher completes a batch successfully, a notification is fired and a listener is executed. This listener can be configured to any number of things. Think of some of your scenarios. Maybe you want to send an email or do some additional logging. However, in our case, we made an additional remote server call back to the Data Hub service. From here, we kicked off additional harmonization processes at the Data Hub service. To do this, we use the Data Hub SDK. The MarkLogic Data Hub SDK executes a particular flow. This is part of the consumer thread, specifically the thread that batch is running in. And the SDK is used to run that particular flow and the steps within that flow. In our case, we configured this to be blocking so we can get an overall timing of the full end-to-end data load. However, you can run this asynchronously if you desire. The flow runner looks a little bit like this. We're listening to the action that comes from the batch. We fire up the flow runner, and the flow runner pulls the URIs for processing and splits those into parallel threads and executes those against the Data Hub service for the work. Those responses will come back, and we log the information regarding the time it took to run the harmonization process, and we log the records that were completed. And this concludes how we get to the numbers for the ingress of data. In terms of egress of data, we use the same client SDK within the same JVM. However, in this case, we're making it a remote evaluation call to our search endpoints. We have a representative query that uses the index to create a sum aggregation of the overall purchases within a sales order. We randomize the sales order number that we're sending over, so it's a representative query from a large number of clients, emulating what would happen in the real world. We have multiple threads running, so we can make these calls as quickly as possible. These calls are being made internally to the MarkLogic REST endpoints. The query evaluation looks a little like this. We create the query, we send over the query in a single job thread for that particular sales order number. It connects to the MarkLogic host and sends a response with the sum aggregation. We log the end-to-end time for each one of those and aggregate that on the JVM side to get our overall timings and the number of queries that we can run within a particular time frame. This can also be extended to use a query batcher if you want to further optimize the number of queries that are executed on the MarkLogic side. However, for our case, we wanted to make single queries at a time. This concludes what we did for the load testing. You can further extend this using a number of features within the MarkLogic Java SDK. If you're interested in talking more about the SDK or this particular project, feel free to reach out to myself or Imran. Thank you, and have a nice day.